welcome to another WJEC A level physics question. This time it's question 1 from the January 2005 Unit 4. It's a momentum question which nowadays you'll find in Unit 1. To start with, we're going to state the principle of conservation of momentum, and we're given 2 marks for this. Now, I've seen very often students will write down something like momentum before equals momentum after, and that actually scores them 0 marks. Because what we've got to realise is that this principle tells us that there's no change in the total momentum in the interaction. So if we find the total momentum before, it's going to be exactly the same as the total momentum afterwards. So that's probably the easiest way of getting the first mark here. So the total momentum before an interaction is equal to the total momentum afterwards. That gets us the first mark. The second mark is that there's a provided here, and that provided is that there are no external forces acting. For the next part of the question, we've got 2 empty supermarket trolleys, each of a mass of 20 kilograms and nested, jammed in together with one wedged inside the other. And a pair of trolleys is moving forwards at 1.5 meters per second when a third trolley of mass 20 kilograms as well, moving at 8 meters per second, nests with a pair, and after the collision the 3 nested trolleys are moving at some unknown speed v. And we're going to apply the principle of conservation of momentum to show that v is 3.7 meters per second. So as momentum's a vector quantity, we're going to take the forward direction as positive. There's no movement in the opposite direction, so it's not a point that we have to have, but it's a good habit to get into. So I like to write each object's momentum in a bracket. So we've got the 8 meter per second 20 kilogram object, and we've also got the 40 kilogram object moving at 1.5 meters per second. So that's the momentum of that, and that's the momentum of that. And after the collision, we've got the 3 trolleys of a total mass of 60 move at an unknown speed v. So here we could do a little bit of cancelling if we like. Don't have to. Can just save a tiny little bit of working at the end. So on the left hand side here, we've got 8 times 1 is 8, plus 2 times 1.5, which is 3, and 8.5 is 11. So 11 is 3v. V therefore is 11 over 3, which is 3.6 recurring meters per second, or basically the 3.7 meters per second that we had to show. Next, we've got to calculate the mean force acting on the left-hand trolley during the collision if this collision takes place in a time of 0.5 seconds. So here we can use Newton's second law, which is basically that the resultant force acting on an object is its rate of change of momentum, the change of momentum divided by the time. So the left-hand trolley's momentum has gone from 8 meters per second with its mass of 20 down to 3.7 meters per second, and its mass is still 20. And the time that it took for this was 0.5 seconds. So if we put that into the calculator, we end up with 173.3 recurring newtons. So 173 newtons will be more than enough significant figures here. After the collision, the 3 nested trolleys come to rest in a time of 4.0 seconds, and we've got to calculate the mean resistive force acting on them. So we can do exactly the same type of calculation. The change of momentum of the trolleys, well, their total mass was 60, and they were moving at 3.7 meters per second, and they come to a rest, so their final momentum is 0 in a time of 4 seconds. So let's put that into the calculator. And we end up with exactly 55 newtons. Finally, we've got to comment on the validity of applying the principle of conservation of momentum to the collision. Well, remember that provided part of the definition earlier, provided there are no external forces acting. Well, in this collision between these two trolleys, there's bound to be external forces, like frictional forces with the ground, etc. So just say something like there are external forces acting. So it's not completely valid. Thank you very much for listening. Please remember to like and subscribe, and feel free to ask any questions in the comments. Goodbye.